So, yeah, like it was said, I'm going to talk about a language that was built on top of the Erlang virtual machine. Although I would kind of disagree with the syntax thing, although for many people it has been sort of a problem with Erlang with the syntax, but for me it wasn't. I was doing Erlang since 2001-ish, so that wasn't really a big deal for me. But what was a big deal is that the language itself was not allowing me to do certain interesting things with it. And I've been trying to find something, and I think I sort of found a good compromise on that. And that has been Elixir. So there's a quote from Yurii Rashkovskii. So, and whether you can see it, but it says, Lisp traditionally empowered developers because you can eliminate anything that's tedious through macros, and that power is really what people keep going back for. And I think I kind of agree with that statement. So what is metaprogramming? So how many people of you in this room have their definition of metaprogramming, whatever that is? Because different people define it differently, but how many people? Okay, so probably 30%. So the way I'm trying to define this is in a very practical sense. So for me, it's a program that writes a program. That's about it. I think it's good enough, and we all write programs, but why not writing programs that do write programs? And that obviously will simplify our lives. Well, at least that's the idea. So somewhat practical examples that I can think of. So domain-specific languages. When you have a domain where you need to operate with certain entities and certain ways to describe things, it obviously is more convenient to describe them in that specific language rather than a higher level abstraction that would unnecessarily overcomplicate the details of your specifics of your domain. The other good example, and I will be showing a little bit of that a little bit later, it's embedded databases. When you want to have some certain database in your program and access it very quickly, so basically it is embedded into your functions, such as, say, Unicode tables or MIME types database. It would be great to generate that code. Obviously, you don't want to take a Unicode database and then hand by hand just for every code point and every sequence write a function. Obviously, that's not practical. That you can use code generation for. Conditional compilation. Well, we all know for things. For example, in Erlang, you can do if-def and then just do something. But what if our conditions are more complicated than, say, a definition of certain variable? If we want to depend on just about anything around us to make things happen or not have it or have it in a different way? That's another case for a program that writes a program. Another one is code that generating code that does dispatching. So for example, think about a very, very simple example. You have a web application and you're routing certain requests to different different controllers. And most of the time what is done, you have the framework that parses your native definition in some way. Sometimes it's the native code in that language, or sometimes it's just some sort of text file that maps URLs to particular controllers. So it has to read and maintain it as some sort of dictionary or a map, and then just whenever the request comes in, it scans the table and sends the request. Why not have this implemented in a code that automatically redirects those requests without looking up in an actual map, but just there's enough code that figures out, okay, this comes from this comes for this rule, so we'll dispatch it there. That's another example. And another example is precompiled templates. So you can read a template out of a file, so you don't really have to read the file runtime, because, well, that's definitely an I/O penalty. You don't want that. Why not insert in a function that will always produce the result of that template with the variables inserted in it? So here's an example of some Python to C metaprogramming. You probably won't see much, but I can do something about it like this. So you see they basically print and generate some C code. So this is part of their way to build Unicode stuff. So they want Unicode to be as efficient as they can get it, and they're just generating C code. and throughout the compilation process, this somehow gets to GCC, and they get Unicode. Another example, that's actually Elixir to Elixir. It's not the whole thing, it's just an extraction. But it actually does the very same thing, except we're not generating in C. We're generating essentially Elixir and Erlang by proxy Erlang code. So here we're just scanning through the code points and generating the, here it is, the next graphene function that basically figures out the next graphene for every set of code points. This. Here we go. So let's make it easier because those examples were obviously a little bit complicated. So let's start from the very beginning. So how about we define a module hello, and we have a function called world that just prints hello world. But there's an interesting thing. If you compare that to a regular definition of the module in Erlang, you would see that there is another output just in the middle of the module. So when is this thing going to be executed? Any guesses? Okay, so the guess was at one time, but let's try this. So the first command is an Elixir compiler. So we're compiling the file that contains the code. And as you can see, there is a message .out. So it's actually compile time. So what that means, the def module construct itself is a program. So it can define a function or it can print something just in the middle of the definitions, because it is just a regular program. So what was that? So the idea here is that everything is an expression. So in Erlang, for example, they have a special syntax for defining the module. So write dash module, the name of the module, and define exports, make includes. And those are sort of special because they're not part of the actual language. They're just part of the way you define a module. So they're just different expressions, and you can't really have, for example, that's the reason why you can't have them in the shell. It's just something particularly important for the compiler, but not for the language itself. So that's the main difference that we have here. So that's what I was saying. You can't really make it execute your own code compile time. You pretty much have to rely on conditional compilation features such as ifdef that everybody knows from C. And obviously, technically, yeah, you can sort of do that, but you'll be really, really sore because parse transform monsters will just come and get you. And then how do I know that? I wrote a lot of that. So I wrote secubind, exporty, and really insane, other really insane things. They're not actually slightly insane, they're quite insane. So yeah, so just believe me, you don't want to do that. Although you can try it, it's fun, but no. So yeah, everything is an expression, but that's not enough. Macros. So is anybody familiar with Lisp here? Awesome, that's actually lots of hands. So you'll find yourself almost at home. So we have quote, unquote, and unquote splicing, which is, I think in different Lisp, well, in common Lisp, I think it's comma at the unquote splicing. So you can unquote the list, but not as a list, but just as a well, just a couple of elements out of that list. So here's an example that I'll show. Even though the Elixir language itself has the unless construct, which is implemented in a very similar way, just a little bit more complicated, but a tiny bit. So let's pretend that we only have a construct of if, which we can see at the bottom, where we say if not available, do something. But what we do here, we say, well, here's a macro unless, and it takes a condition, so it's basically an expression, and then it takes some options. So we quote if unquote condition, so we're extracting the condition into that syntax tree, and then we're putting all the options, like basically it's going to be all the options that if accepts, and that's normally the do option and the else option. So what do we do if it's true, and what do we do if it's false? And right after that we can use else available do something construct which will be the exact opposite of if. And obviously, the good part about it, as you can see, it has the very same syntax as if. So it feels like part of the language, even though it might not be part of the language. So you can't even really distinguish them. They become part of your language that you define for yourself. So what exactly enables this? So unlike in Erlang, where the way you can see the AST nodes in Erlang, they're in length and they're structured a bit. So they can be tuples of 3, tuples of 4, I think sometimes in tuples of 5. So you have to write fairly complex code to understand what's going on inside. Here, for all data that is not a literal, like number or a string, something like that, it's a very simple format of a tuple of 3 elements, where the first one is the name of a sort of a function, then some metadata, usually it's a line number, sometimes it's a little bit of scoping information, so it's pretty internal to the compiler. You almost never do that yourself, but in some cases you do. And the second one is arguments. So let's see how some things work in this. So here's a 1 + 1 expression. So we say the name is plus, and you see it? I guess you can just make it a little bigger. So then I'm totally skipping meta information because it's not important here. And the arguments are 1 and 1. So it's plus 1 and 1. So if we go a little further, so this is IO format hello in Erlang. And it looks a little bit different in Elixir, as you can see on the 3rd line. But this is how it is represented in Elixir AST nodes. So in the first one, you can see the name of the operation is a dot. Then again, we're skipping meta, and we're saying IO format. So basically, we are connecting the name of the module and the name of the function using the dot operation of a sort. Then again, we're skipping the higher level meta and just one argument, hello. So we're always using these construct, and it really makes everything easy to process for the compiler and for the developer who writes this. Although most of the time you actually never see this, because this you only need when you're going really deep with your macros. Sometimes you have to break into the actual representation of the nodes. But if you're doing something as simple as the previous example of unless, you never actually hit that, and you might just be ignorant about that part. But this is a very important part of the compiler itself. This is kind of a cornerstone here. And it's very easy to explore in our REPL called IX. So what you can do, you can throw an expression at it and just see how it looks. So this is a real example. So here, part of the metadata says just we're importing the kernel module, which is again only important to the compiler, really, or maybe for some analysis tools that haven't been written yet. And you can see plus 1 + 1 thing. So basically that means you can just toy with the representation of things. So for example, if you write in a macro and you do want to match on different ways your input data is coming, you can see how it actually looks like without trying to figure that out yourself. So why do we need macros again? Because of that. Because that eliminates everything that is tedious, and it makes you focus on the real problem, not the way you're doing it. Great, so we have macros, we have AST nodes, we have some code generation, but now what? What is Elixir? Is it just macros, another way to represent AST for Erlang? Well, not quite. It actually is much more. So it turned out it has been in development for about 2 years now, a bit more than 2 years actually, and it turned out to be a really great collection of interesting stuff. So who's familiar with Clojure here? Great. So we have protocols that are very similar to Clojure protocols, not exact replica, but something similar. We have a sort of more uniformly standardized library comparing to Erlang, because the Erlang standard library does not really have consistency in naming, sometimes even in what kind of index to take, and other things that I'll cover a little bit later. We have a better shell in the way that it knows a bit more about the system and can show some interesting things that I will show later on. We have an actual support for Unicode strings, so we can do graphemes, uppercase, lowercase, correct length, so the basic operations. We don't have everything yet, like sorting and stuff like that, but it's coming. But at least we've covered the main operations, and we've covered them in a way that I was actually showing, and then probably we'll talk a little bit more about that later, and obviously more stuff. And it is still Erlang, so the code that you produce is not something different. So there's no compiler or interpreter on top of it to process it at runtime. It basically produces a very valid Erlang AST, which is taken over by the Erlang compiler and is compiled down to the actual bytecode. So there is no penalty for communicating with other Erlang libraries. So whatever is available to Erlang, you can use from Elixir. And whatever is available for Elixir, and we're getting more and more libraries these days, it can be used from Erlang. So we're getting the best of the both worlds, which is kind of great. So look at our highlights. So protocols, for those who are not familiar with Clojure. So the problem really is, imagine you're writing a library to work with JSON, and you're thinking, okay, so I need to process different kind of literals like strings and integers, floats, all the kind of stuff. So I'm just writing pattern matching code that takes this, this, and this, and converts it to an actual JSON. But what if I'm a user of your library and I think, well, I have actually, for example, this record or this other data type like an atom, and I still want that to be in JSON, but I don't want to do one step when I pre-process data, then send it off to your JSON encoding routine. So what do I do? Well, basically, in Erlang, you need to fork the library, add your pattern match for, well, the clause for that your type of yours, and well, leave with your fork, merge changes from the upstream, so all that kind of stuff, which is kind of sad, because why would you need to do that, especially when the change that you want to make is not really shareable with the rest of the world. It's just important for you, but nobody else. Not great. So what we can do here in Elixir is we can use protocols. So protocol is just like an interface in Java sort of kind of thing, where you define what kind of functions the protocol should implement, or even must implement in this case. Then you define individual modules. Well, in this case, we're implementing them for a string and an integer, and they define how do we do this for strings, how do we do this for integers, and that means that, for example, if the original author did not cover the case of, say, atom, then, well, basically just write a JSON encoder implementation for atom, and you don't need to modify the original library, but you get the very same integration with that library just for free, and it will work at the same speed. So that's pretty great, and you don't need to fork anything, which is fantastic. So those were protocols. By the way, if I'm going a little too fast, just let me know. But if any questions, I can answer. Just stop me and ask right on the spot.
Quick question for you then.
Sure.
That's the slide you were just on.
Yep.
Can you define an implementation for a protocol in two separate files? In other words, if you have a main protocol implementation.
Oh, yeah. Absolutely, absolutely. It doesn't really matter. You can define them anytime. So, for example, you have the original library compiled 2 weeks ago, and then in your own project, for example, you want to cover that case again with atom conversion to JSON, right? You just write that anywhere you want, anywhere in your project, because the naming will be the same. Basically, the protocol, the dev protocol construct, what it does basically, it creates tons of dispatching code for you, and it will be sitting in the JSON encoder module. And it doesn't know, ahead of time whether you'll have implementation for anything, because the modules are decoupled in Erlang. Although we are planning the sort of optimization on that, so that you can define an embedded implementation for certain types, just to make the actual dispatching go even faster. So the types, you will always be dispatching there. So like core types kind of thing. But generally speaking, yeah, you can do them anywhere, anytime. Right. So
Can you override like an existing implementation inside like a a different module, why not have it only be valid within that module?
Well, so basically you mean you have an existing module defined by some library?
So like somebody else has defined existing code for string, and just inside of my module, I want to use a different implementation.
Well, it has to be global, sort of, because the modules are global in Erlang. So yes, you can override something provided by the library as long as you ensure the correct compilation order, so that your main file for the module gets there last. And then, well, then you have to make sure it actually gets, like in your path definition, it gets in the beginning. So when Erlang is looking out for it, it finds it first. So there are some minor difficulties with that, but you can do that. Huh? It is generally a bad idea, but yeah, it's technically possible. But again, monsters will come and get you for that. Any other questions? No? Good. So standard library. So what we have improved, one of the really greatest things that I really like about Elixir is the enum module. Basically, what it allows you to do is to apply all those sort of Lisp operations like map, fold, which we call reduce, map, fold, and say each, all those operations. There's like over 20 of them. To anything that implements an enum iterator protocol. So just to give an example, okay, let's make it bigger. So here we use an enum filter function. The filter function is basically something that takes, well, in Erlang it takes a list and applies the function to every element. And if it returns true, then it keeps it. If it returns false, it discards it from the list. But here you can see that the list that is being passed is not actually a list. It's an iterator structure from the file module for the etc sort file. So what it means, it will iterate every line. So it actually doesn't read the whole file ahead of time, but every time filter meets a new element, it will fetch it from there. So technically speaking, it can be very long, and then you still don't consume as much memory as you would if it was a really big file. And it gets back to filter. Filter decides whether it's positive or negative, and proceeds. So here you can see that the first result, usually in those databases, especially on Macs, they have a couple of lines as comments. So here we don't have that because we're just checking that. So that the first character of that string is not a comment. So this can allow us to produce really concise code and still use those famous functional programming primitives, such as filter, which is kind of great and convenient. And this is actually all due to the power of protocols. That's how enum module works through the protocol. So we're going a little bit back. So the dict API. So a lot of seasoned and newbies in Erlang have noticed that Erlang has at least 4 implementations for structure like dictionary of some sort. They have or dicts, they have dict, they have GB trees, and some, I think one more, I don't remember. And well, propolis is kind of, yeah, that's almost or dict, but because it doesn't have to be sorted. And the problem is the APIs are different, the naming is inconsistent, and once you have chosen structure, you can't change it. Just like the whole API will be different. So this is really unfortunate because you thought there will be like 10 elements and or dict will work just fine because it's just a plain structure. But then you realize no, it's actually not 10, but it's 10,000. Now you have to really understand how to change all the calls to that particular API for that particular type of dictionary. So instead of that, again, using protocols, there is a dict API available for all kinds of dictionaries that you can possibly imagine. You can implement your own dictionary. And as long as you can say it's part of the dictionary family, you can use the same API. So you can just switch the implementation immediately. It just works. So for example, what I was doing with it, actually I was doing this with enum, but we can do that with dict as well. I was taking different database engines like ETS and some external ones from Basho, and I was implementing those protocols for actual databases. So instead of using ETS API, why? Like, there's a dictionary API for key value at least. If all I need is key value, dict is great, right? I don't need any kind of selection or cursor kind of stuff. I can just use that. And today it's ETS, tomorrow it's level D, whatever. It works. So the other thing we improved and worked on the file and path module, so it's a little bit more consistent than what we have in Erlang, and the error reporting is a little bit better. And finally, functions like recursive copy and recursive directory deletion, just stuff that makes sense, right? I mean, they have to be there, but for some reason they're not in the standard library in Erlang. Another thing, and those who already know Erlang, they know that most of the stuff in Erlang is the indexing is based on at1, so list at1 is basically the first element, but when you start working with things like binaries, you suddenly realize they're actually not 1-based, but 0-based, so it's a little bit of inconsistency, you have to remember it. And there's a lot of people who say, well, 0 is wrong, 1 is correct, but the thing is, most of the industry is using 0, and they just have this big problem with 0. So we just, after a little bit of debates, we decided, okay, let's just make it all 0-based and just forget the whole thing. It's not as important. And lots of goodies that every standard library should have, but for some reason Erlang doesn't. For example, there's an option parser.
About zero-based indexing, do you know which Erlang methods that end up getting called return or one-based numbers, and you subtract one from all of those?
Well, basically, yeah, we do that. When we use, when we just proxy to Erlang functions, and we know that they're using one-based indices, then we just, well, we increment it by one.
Parameters
Yeah,
as a result.
yeah, just, but it's, well, sometimes when it doesn't really make sense to proxy to Erlang, so that code is not actually implemented in C. For example, we just would consider it re-implemented ourselves if it's not too complicated. So yeah, and about the goodies, so stuff, for example, like parsing command line arguments or parsing URLs. For some reason, it's not Erlang, but it's just things that are so common. So for example, in Erlang, there is a module called getout, but it's not part of Erlang. So if you're writing just an eScript, which is an Erlang program that just gets interpreted or compiled at the time of launch, so it's a script. But you want to parse, obviously, your command line arguments, right? And then you have to have this another module which is not part of Erlang, so you kind of have to write it yourself. Kind of sucks, right? Or the same thing with your URLs, URIs. So we just have it in Elixir, and we just keep that stuff there. And actually, recently we even added stuff for escaping IO. Well, the ANSI color sequences. So for scripts to make use of colors in the terminal, it's just part of the standard library. So you can write scripts that produce more readable results because they're color-coded. Again, it's stuff that is not really that important, but in the daily life it is. It actually comes up as important eventually. When you need that productivity, you need those small tools. They kind of seem not a big deal, but at the end of the day, they are a big deal. So that I showed already. So first class shell, what do I mean by that? So there are three important things for me there. You can actually define modules right while you're sitting in the shell. Instead of, in Erlang, you actually have to just switch to another tab or to Emacs, create a module, compile it, and then go back to the, well, you can compile it from the shell. But then you have to switch back and forth with the editor just to basically do all this stuff.
Do they have a design reason for that?
Pretty much, because like I was saying in the beginning, Erlang, the way Erlang defines a module is basically sort of two syntaxes. Right? So there is a way to define a module, which is using the forms of the module, but there are like expressions of the function kind of stuff. But the format for the module is not part of the actual syntax. So you have to do the file thing. Here we don't care about the file really, because again you can have multiple modules per file. So you can just basically that module construct is actually a call to an internal macro that receives certain arguments and just does the assembly of the module. That's why it's actually possible to do that right in the shell. So kind of a design issue here. So the other thing, probably most of you are not familiar with that yet, but who's familiar with the fact that Erlang has a way to define data types and the specifications for types of functions, well, signatures of functions, basically. So, yeah, a few of you. So in the Erlang shell, it's not possible to explore the types or functions of the in the modules that you're using. You actually have to go to the source code to find them. That's a long process. And the other one in Erlang, you have, if you want to read the documentation, you're either using man or using one of the websites to find your documentation. Why don't you have it right in the shell? It just makes so much sense. So I'll just show a little bit here. So this is about types. So there's this enum module, and I just wanted to know what kind of types are available there. So I'm just typing t enum, and it prints there's a type t. So it's enum.t effectively, which is another active type actually. And there's element type, and there's an index type, which is just a non-negative integer. So I can see that. If we go a little bit further, we can see the enum. So I'm basically asking, can you give me the signature for all functions that are called sort in the enum module, whatever the arity of those function is, and it gives me two of them, so sort1 and sort2. So the second element is a syntax for defining type for a function. So it takes like an element and returns both, because it's sorting the elements, and then returns a new list. So I can see that right from the shell. And the third one is even more obvious. I'm just asking, like, what does that function do? I'm just asking, well, h enum map. And the actual documentation is a little longer than this, but this is just the beginning of it. But you can explore that right when you're playing with the language or just trying to engage into an actual sort of REPL process as it was supposed to be since ever REPL as an idea emerged. So we can sort of stay in that environment for quite some time and get everything out of there. And the reason, by the way, the reason for this is because we have embedded documentation. So when you're writing the code in Elixir, you can specify a doc attribute before any of your functions, and will automatically get collected by the compiler and put in the right place, so that later on you can use it for standard library, your own library, it doesn't matter. So it's a feature available to everybody. Another highlight, Unicode. So it has, like I said, basic primitives and operations. Like we actually support graphemes, and we have all those length, add, upcase, downcase, and a few more operations available. It's actually under 200 lines of code, but it generates a beam file, so the byte code file, that is over 250 kilobytes. And that's basically because it reads the Unicode data.txt and a few more other files, and just produces tons of code. But it's actually quite fast, depending on your machine. I've seen anywhere from 8 to 20 microseconds for standard operations on average length strings, like with somebody's name or something. It's actually pretty good. The Python implementation that is actually in C, so it's as fast as it can get. For the similar operations on the same hardware where I was getting 8 to 9 microseconds, it was 4 microseconds for those operations. But that's C, right? It's obviously more optimized for speed than Erlang. And this is still plain Erlang that produces only 2 times slower than C. Not bad. And it doesn't have a bottleneck. So one of the implementations for Unicode that I've seen in Erlang, it actually makes a crazy use of gen servers, local process caching, and just about any technique, just to get around the fact that we're reading the file and then serving it to every client. But when you have a server serving those functions for strings for everybody, it becomes a bottleneck quickly if you're doing a lot of string operations. But since this does not use any of messaging or concurrency primitives in Erlang, it's just plain functions that return certain values for certain combinations of code points. It can scale really well. Like if you have 100 cores, whatever. If Erlang can scale to 100 cores, this can scale as well. So what's the status of the development? So it's actually, like I said, it's been around for 2 years and 1 month. We're preparing the next release to come out actually within just a couple of days. So we just recently released 0.8 about a week or 2 ago, 2 weeks ago actually. And this release is just bug fixes and new improvements and a few other interesting tidbits coming up anytime soon. The community is really growing. So for example, even just a couple of months ago, I remember our IRC channel, it's mentioned over there, it's Elixir-LAM. We had about 40 members just in the channel. These days it's usually 65-ish. So even just by that metric, I can see there's a lot more interest. And we have more activity in the mailing list, on GitHub, so more contributions, more issues being open. So we can obviously tell that there's definitely some growth happening. And the pace of the development is really good. I'm pretty sure we'll be able to get to 1.0 this year. Obviously, I hope that's going to happen within, say, half a year. But let's see how it goes as well. 1.0 is a major milestone. So, and we also have package management. It's called XPM. So you can find it at xpm.co. It's obviously implemented in Elixir. We have a little bit over 40 packages. Most of them are Elixir packages. Some of them are just Erlang packages because the repository is not limited to Elixir. It's open for all languages based on the platform. Say Joxa, Erlang, LFE, they can all make use of it. So far it's only been used by the Elixir community and a little bit by Erlang community, but everybody's open to use that. Basically, this is a result of my previous work that I've done in the Erlang community. Some of you may know the tools like Agner, so that was a repo for Erlang packages. So this is a sort of next iteration that I kind of rethought the way package management should be done, and I'm trying to go with it now and see how it works. So yeah, try it out and questions.
Well, how do you compile stuff? I mean, for example, I can make a macro, right? And then I can make a macro from the macro, or with the macro. So how does that get translated into the VM at compile time?
So yeah, the question how the macros are getting compiled. The idea is that macros are essentially, they are just functions, technically speaking, right? They just accept not sort of regular values, but the AST representation of the code as arguments. So during the compile time, they just keep producing AST until every macro is resolved, sort of like expanded to its final value. And then all that code, all those calls, they are getting compiled to Erlang, like Erlang AST. So it's something that Erlang compiler understands. So that's a good thing that Erlang compiler understands not only its source form, but also the intermediate AST representation as an input. So that we're just feeding that into the Erlang compiler, and it takes it from there during all the. So you're basically getting everything, including the optimizations available in Erlang. So does that answer your question?
Yes.
So one thing I want to say is, like, I'm super impressed by how fast you and Jose have been moving. It's incredible. To me, like, the macro set is less important. It's cool. It's like fundamental of the language, but like it's writing like a gin server in 2 lines of code. And so I don't know, like, if you had extra time or maybe Lightning Node or something, if you could show people that, to me that would be really cool, because it would show people using something that's really inherent and like super fundamental to Erlang, but like in Elixir. That's the thing that blew me away. Like, we started using it for little internal projects. It's like that sense when you do that first Ruby active record, like class definition, you just do the little inherit from active record, and you're like, wow, I've saved like months of Java getters and setters. That's really cool.
Right.
It's the same feeling. You know what I mean? I don't know. Just food for thought. Something to think about.
Yeah. Let me think of this. Like, I'll answer other questions, and
Yeah,
let me
like,
think what I can show right on spot.
Okay.
Yeah, all right. So.
Is anybody talking about IDE plugin for Elixir at this point? Like,
For what IDE though?
for Eclipse?
I have no idea about that. I know there is, well, I'm using Sublime Editor, so there is sort of more or less working mode for that. There is a fork of the Max mode maintained by one of the guys in IRC. He plans to send it in to the original author. that seems to work pretty well. There is a vim node for sure. Definitely know what the unknown groups. So just don't know. Any question? That's a question.
I have two questions.
All right.
Well, what do the stack traces look like? Are they convoluted or are they?
Basically, whenever it's in our control, basically whenever we are handling that, we're printing them in as nicely as possible. Especially in case of when we're running unit tests, like we have our own XUnit framework, which is kind of like JUnit-ish DSL. So we're even trying to filter out parts of the stack trace that are not part of your actual test. So we're basically, just to give you an idea, Joxa is coming from the Ruby world, and they do try making things really nice and make kind of sense, not produce anything that is really not that important. So yeah, we're trying to do the best at that. Sometimes it's not always possible, especially when you're using things like logger. Sometimes it's just not really not control how we print stuff, but yeah, we do tend to print them very nicely.
Okay. And it's showing actual Elixir.
So we're using line numbers because we have a requirement for R15. You cannot use it on R14. Okay. So we always have the line number information.
Oh.
So what's the second question?
The second one is for somebody who's just getting into Erlang. Would you recommend they use Elixir or should they learn basic learning syntax first?
I would personally suggest. Oh, so yeah, I think not everybody heard the question. So the question is, should we get, like newbies, should they get an Elixir first or Erlang first, right? I would suggest either, but I would suggest to do both because it's still part of the same infrastructure. Like if you're no Clojure, chances are you know Java. You pretty much have to know Java if you're doing Clojure or Scala, right? So the very same way with Elixir, start with whatever you want, but figure out both, because it's quite important. Because you'll be using libraries, say from Erlang, you need to be able to read them, right? So that they make sense to you.
Can I maybe interject? I would propose that you learn learn Elixir first, because that'll force them to learn some of these things that are very useful and very cool that they might not have known, and the Erlang that they need, they won't have a choice. They'll be on a wall if they don't learn it, so they'll be forced to learn it. Whereas if you just learn Erlang, at no point when you're programming in Erlang will you be forced to learn Elixir. Like you might just go on forever programming Erlang without knowing what you're missing.
Yeah,
So just for that reason, I would do it Elixir first for a newbie.
So you're saying it's like a steeper learning curve, but at the end of it you learn everything?
Well, it's just that since Elixir is really on top, if you learn Elixir, you will end up having to learn some Erlang anyway. Whereas if you just start with Erlang, you won't have to learn Elixir. And probably for many newbies who come from Python or Ruby or other languages like that, it's easier to learn. Sorry, go on.
I'm a newbie and basically have a background in Ruby. When I look at the language the first time, I don't have a problem with the syntax or things like that. Actually I like it. But I think, is there anything that close to Ruby that I can play around with and look at Elixir? And the first question that comes to my mind is, there is a lot of inconsistency in the library or some other thing that you mentioned in the slides. Why don't we make that improvement into the Erlang stuff instead of try to create Elixir that is kind of Ruby-like or JavaScript-like? Why not just make it into an Erlang, make it consistent, make it like always going to be indexed by single dot. Why not doing that? Why we do this issue?
Yeah, that's actually a great question, and we had a couple of debates about that. So I think I can sort of answer this question. So the real answer is that the way the standard library in Elixir is built, it's using all those concepts that it's it has a sort of foundation, right? Like protocols and stuff. And the only reasonable way to do protocols is to generate lots of code for that. And that's not a very sustainable sort of approach for Erlang because you have to write parse transformation, and that's really horrible. So basically, making this into Erlang would be a difficult problem, although solvable problem. let's put it this way, most of Erlang developers are sort of used to the library, although obviously not everybody agrees with the way it is, especially when it comes to things like inconsistencies in dictionary interfaces. But the thing is, it would be a very complicated political question even to move this into the standard library. Just probably not worth the effort. Because if you look at how Erlang evolves, it is a pretty old project, and it's not very acceptive of new changes. So it does change, but something as big as a standard library. Because there's no point of a standard library that is not actually a standard library, right? It's kind of a standard library for 3 guys, right? It's just like not important, right? So it's not going to be used by everybody. But for this reason, and for the reasons that the way the Elixir library is designed, it's making a heavy use of macros that are only available in this way for Elixir that make the programming of the standard library actually convenient. These methods are not actually available in Erlang. They're only available in some very convoluted way. So it's just nobody would actually love doing that. But this is more of a fun kind of. Well, this is at least my idea of having some fun time. I don't like the idea of taking like parse transformations in Erlang. What they do, they take the actual compiled syntax tree and then you kind of rewrite it. It's kind of backwards or convoluted in some sense. So I guess that's going to be the answer. It's just it's a political issue, it's a technical issue, and why not, right? Kind of answer as well. As long as we're creating a new language and we have certain concepts in mind, why not just stick to it? We do contribute as much as we can back to Erlang, especially bug fixes or at least bug reports. We are considering contributing our new implementation of the hash dictionary. Well, the dictionary. We have a new dictionary that is actually more efficient than any other Erlang dictionary implementation. So not only obviously conforms to the standard interface, it's actually faster for different sizes of dictionaries. Jose, who actually implemented that, he said, well, if Erlang people want that, we'll actually consider helping port it, or even we'll port it ourselves back to Erlang. So we are fine with, obviously working with the Erlang community to help contributing to their library. But obviously we're working on our project. It's just, that's the goal that we have, and we have a vision for it. But what we can, we are contributing, and we will be contributing back to Erlang as much as we can. Does that answer your question?
Not that. But I do understand it's more likely to be a political issue. And
I would say it's probably 50% political question. So. All right. Any more questions?
I noticed that what seems to be a do block. Are those actual blocks or are those syntax?
It's actually a syntax trigger. So let me actually show this. It's just easier to show this. So basically, let's say def module. So you have seen the way, I'm not putting any functions here, just to make it concise. So here you can see the def module a do block, right? So there's do add. But what it actually means to the compiler is, since I'm not putting anything, so it's a nil. So this is the actual call. So this, and if you'll start looking at those numbers, this is actual binary representation of the module. If you look at them, they actually look the same, and they should look the same. So what is this structure? Let's say do nil or A1, just whatever that is. It's actually an absolute equivalent to this, or we can even do 2 of them, for example, A1. Right, so it's actually getting printed out with that syntax. So this is just a syntax trigger for prop lists, as they call in Erlang, but they make it for more readable code because you don't have to read through all the brackets. Right, it just kind of makes sense. And the do end and a few other things like, well, it's mostly do end, but there's just a few minor cases in the parser that basically. Yeah, for the compiler, it is the same as do nil. It's just, for the user, obviously, it's more convenient to see them as sort of do blocks. They're no different, because if you have something like this, so we're doing quote, just to see how quote is represented, and then we're saying def a do 1 plus 1, right? Like this. So we're trying to see what is the expression for the expression of the function definition. And it says def, then the second one, as I said, let's give it, it's not important. It's for the compiler. And then you'll see it says A with, well, this is arguments, this is guards. It doesn't have any of those. But then, see, it has the do, we call it a keyword list, basically, keywords, when we're using that syntax. And see, the only element here is the plus function. And obviously, if it was 2, it would just do a block of them, so that it ends up a list of operations. But as you can see, to the compiler, it does look the same. It's essentially a style question. So you can write always by using the keyword syntax, and actually just to show some other example in this area. So instead of writing in the way I just did, with do and NLog, for really short functions, you can do something like this. And why this works is because essentially, again, so the first step, it actually looks this way to the compiler. Def is not a special thing. It's actually an internal macro that accepts a couple of arguments, in this case 2. One is it actually will look more like this internally as an AST, but for the simplicity in this way. And then this. So how does this get interpreted? Is actually it's get interpreted like this. Just like in Ruby, you can omit the brackets for the last argument, so that it just looks sort of easier when you again remove all the parents. It looks like natural language and not just like tons of different parents and brackets. But again, it looks the very same way. So if we just close this and do quote do and then do def a. So if you compare this and this, in minor ways they are different, but that's not important. Like the meta information is a little bit different. But as you can see, it's the same do block. It's the same do keyword. Does that make sense?
Yeah, will those do blocks capture variables?
Hmm?
Will those capture variables?
What do you mean? Like
Well,
capturing?
in Ruby, you can pass the do block around, but it looks
Yeah,
like
but
it's
so
just
no.
it's
Here
a
it's
matter
just a syntax thing. So basically, whenever you need something like a do block, it's actually just an anonymous function. And this you can, for example, if it's argumentless, you can just do this, or the same thing, this. It's just like normal, basically just the fun. Except for they call it fun, we call it fn, just for the brevity of it. So yeah, that's the actual block. So we're not trying to invent anything really new on top of Erlang primitives. We're just giving to them, and we're not calling functions blocks or anything. It's just essentially just a syntax thing. So it has nothing to do with actual closures.
Philosophically, it kind of reminds me of CoffeeScript in a way, and that it produces Conscript produces JavaScript, although maybe that's not
On a very high level, I can agree with that. On a deeper level, I won't, because basically the problem with CoffeeScript is that it does not give you tools to extend the language, to use macro facility, right? And this is a very, very fundamental issue in Elixir. So I partially agree, but generally I don't. It's a different level of sort of improvement on top of the language. This CoffeeScript is just a syntax improvement, while this is a conceptual improvement in a way how we compile stuff. It's quite different, because you're basically in control of the compilation cycle, because you can program it yourself.
maybe that's not.
It's
that's not
on the very high level that's a good analogy, but I think in the end it's harmful analogy because it leads you, into making certain assumptions.
Right.
Right.
Well, the assumption I was making is like, CoffeeScript should protect you against some of the things that commonly happen in JavaScript, like scoping issues and wrap stuff in anonymous functions. I was just wondering if Elixir, protects you from some common issues you might run into in Erlang, if it does the right thing
general sense, the only way it will prevent you from doing something is by providing a better standard library. So you will make less mistakes because you write less code, better code. In the other regards, we are trying to follow Erlang semantics quite closely. We do have few tweaks to it. So for example, those who know Erlang or have attended the Loop Bootcamp today, you know that in Erlang you cannot reassign a variable, but in Elixir you can do the multiple assignment. So for example, if I say A equals 1, then A equals 2, A will be 2, right? And some people would argue that it's actually makes Elixir mutable, but in fact it isn't, because it's just a different way we shadow variables. So if you want to match them, you just prefix them with caret, and the caret says that it's going to be matching for sure. So this is equivalent to the actual matching operator in Erlang. So this is probably the biggest sort of high-level difference from Erlang's semantics of the code. But the rest, we're trying to stay as close as we can, or let's say reasonably can. If we really think that something's really wrong, we'll probably change that. But we don't really want to make it different from Erlang just so that we can. We would rather make it easier for Erlang developers to just switch over. Because there's no good reason to really change it too much. There are languages that do all that already. Like for example, there is Joxa by Eric. Here somewhere around. Obviously, being a Lisp, that's a kind of different language, and it has a little bit of different semantics, although still close. But again, we're trying to still stick as close, and we're not trying to do too much, like protecting users. In some ways, yeah, we do help with somewhat better error messages that Erlang can. So whenever we can do something better about it, we try to do that. But we're not trying to be too smart about that. We're just trying to make a tool that works. Maybe we'll do something about, I don't know, we don't have a vision for that yet. But after 1.0, we might think about something like that, or if our users will, bring that to our attention that, well, maybe we can do something more about it, then we'll probably do it. Otherwise, just not as important as other issues on our list.
All right, great. Thank you.